Hello, welcome to this tutorial on finding dy dx. This is slightly more tricky than the first tutorial on differentiation because we've got a lot of tricky terms here, fractional terms, negative terms, terms that are in their roots. Now in order to do these, what we need to do is we need to put it into a more, an easier format to actually differentiate these. So I'm going to start off and I'm going to use a number of index laws to simplify this. So the next line, well, I've got an indice here, an index number over x. Now the laws of indices that we're looking at here is if you've got x to the a and you're dividing that by x to the b, we use x to the a minus b. So for this one here, this x is really to the power of 1. So if we do a half, take away 1, this becomes 2x to the negative a half when the x comes up to the top. The second one, we want this out of its root, so this is negative 2 and that becomes x to the half. Root x is x to the half. And then the last term here, when we bring this x to the negative 2 up to the top, it becomes plus 6x to the positive 2. Now we've got all our terms on one line. Now we can differentiate this. So dy dx, and if you remember from the first tutorial, if y equals x to the n, then dy dx is going to equal n to the x, n times x to the n minus 1. So applying this on these three terms here, we're going to get negative a half times 2, which gives you negative 1x. This term goes down by 1, so we get negative 3 over 2. A half times negative 2 just gives us negative x, and here this goes down by 1 again, so that's to the negative a half. And then the last term here, 2 times 6 is 12. We get 12x. This term goes down by 1. We don't need to write the 1. So dy dx, negative x to negative 3 over 2, negative x to the negative half, add 12x. We could then write this in different format, which is a good idea if you want to put values of x into here. So this one would then be minus 1 over x to the positive 3 over 2. Well, the positive 3 over 2 is the same as root x raised to the power of 3. And the second one would be negative 1 over root x, and then plus 12x at the end. This is obviously better if you want to put values for x into there, because you can clearly see that if x was a 4, it would be 1 over root 4, 1 over 2, which is a little bit more difficult to spot if it's in that format. Next one, we've got a different terminology here, function of x. So when we're finding dy dx, this becomes f prime x. But first of all, we've got to simplify this. So we need to get this x out of the root here. So if we take the x out of the root, that's going to become x to the half. So if you imagine there's x to the half on the bottom there, using our index laws again, this first one, well, 6x to the negative a half divided by x to the half, well, this is going to be negative a half, take away a half, which gives you negative 1. So this becomes 6x to the negative 1. The next term here, you've got 3 over 2, take away a half, which just becomes x to the 1. And the last term is already in the correct format to differentiate, minus 6x to the negative 2. Now we can find f prime x, or f dash x. Minus 1 times 6 gives you negative 6x. The power goes down by 1 to negative 2. The x here, well, that's really x to the 1, which becomes 1x to the 0, so that just becomes 1. And the last term, negative 2 times negative 6, gives you a positive 12x, but the power is going to go down by 1. So that's fine, we've got it in that format. If we wanted to change it so it was easier or simpler to put x values in, we can then easily do that, because all we do is this becomes minus 6 over x squared. The negative power becomes positive when you move it to the bottom. The 1 stays, and then again with this one, plus 12 over x to the positive